This is a math review lesson that is going to use our math textbooks today. We have learned about different polygons, we learned about congruent figures, and we also learned about symmetry. That should have been your lesson earlier this week. So we're going to put all of those together as we do a little chapter wrap-up. So grab your textbook, and if you could grab pencil and paper, that would be best too for you to write out your answers. But if nothing else, you'll follow along with this video. Page 338 is where I'm starting from your math textbook today. Now, the first two pages are kind of like math notes. There's just a little review that classifying polygons. Polygons are closed figures with straight lines that make up the polygon. There needs to be at least 3 line segments to form a polygon. Here are some specific names for polygons depending on how many sides they have. Quadrilaterals, though, we've got a lot of names for those 4-sided polygons. Square, rectangle, parallelogram, rhombus, and trapezoid are the ones we've talked about. You can combine and separate polygons to create different shapes. So, for example, a square and a triangle together can form a trapezoid. Now, congruent figures, remember, are figures that have the same shape and size. So they can have moved position, but they are congruent if they have the same shape and the same size. These 2 squares are congruent figures that have just gone through a turn to flip them. And these triangles have also gone through a turn so that the vertex at the top is now pointing to the bottom. To make congruent figures, we slide, flip, and turn them. Those are the 3 terms we used for moving congruent figures. So this represents a side, and the arrow helps you to see that. Slide can also be up and down or diagonal. A flip is a mirror image. So the circle is not the best way to represent that because a circle would also look the same if it was slid or turned, but a flip just is that mirror image. A turn is, imagine like on a clock, is it's just rotating around. So the short side of the rectangle is now facing the side towards the right rather than up top. Then lines of symmetry. A symmetric figure has a line of symmetry, and once you cut or fold down the middle, the 2 halves should be equal or congruent. So this rectangle shows a line of symmetry. If you were to fold those 2 halves of the rectangle, it would completely match up. There wouldn't be any overlap because, as you can see here, that is the exact same length on that side of the rectangle, and these 2 sides of the rectangle are also the same length. This parallelogram would not have a line of symmetry, though, because the vertex here does not have a matching vertex here. Okay, for these ones, I'm going to be filling it in along with you, so I would love for you to actually say the answers as we go through them, and if you can have paper and pencil to write the answers down, that'd be great. So we're using the vocabulary terms on the right here. Oh, sorry, I left an answer because I had done this before, but needed to refilm because of some problems. So for question number 1, we're looking at this figure C, and which of these options would you say describes it? It's an open plane figure, which means it's a plane figure or flat. However, it's not closed in on all sides. As you can see here, there's an opening. So we're just going to write open plane figure. And then I'm going to cross off the ones that I've done. Next, it says a line of blank divides a figure into congruent halves that fit exactly when folded along it. Do you know? Symmetry is the one that we just reviewed on the page before. Okay. Next, it says the figures below are blank and are blank. This is kind of a confusing one because you might be thinking how many sides it has. It's got 5 sides, which makes it a pentagon, which is true. That's not what they're looking for, though. It's looking for, rather than an open plane figure, this is called a closed plane figure. And I had to check our answers from the teacher book for this one because it also would make sense to call them polygons. These figures are polygons, but that's not what they're looking for either. Instead, I want you to tell me what would be the word we use to say that these two are the same shape and size. They are congruent. Great job if you're able to get that. Okay, so if you thought pentagon and polygon, those are correct answers. However, this is what they're wanting you to write for the two figures shown below. The next question says, in a polygon, two sides meet at a point called and we're looking at this part of the polygon, we call that a vertex. Okay. Number 5, a blank has 4 equal sides and 4 angles. Notice it says equal sides. So which of these terms would be best? Now, quadrilateral has 4 sides, but they don't have to be equal. We've got rhombus and parallelogram. Those are both types of quadrilaterals. Which of these has equal sides? A rhombus. Okay. Next, it says a blank has 5 sides and blank has 8 sides. So which of these polygons listed has 5 sides? A pentagon. And which has 8 sides of these ones? Octagon. Okay, great job if you're able to answer that correctly. Next, it says a blank is a quadrilateral with equal and parallel opposite sides. Okay, so which of these has equal and parallel opposite sides? So a parallelogram would be the correct answer for that, and I was double checking the wording of it because a parallelogram doesn't have to have all equal sides, but the two sides that are parallel to each other have to be equal. So that's what it means by that wording, if you were confused. I had to double check myself there to make sure there wasn't square as an option, since that would be accurate, and rhombus would work for that if all 4 sides are equal. Next, it says to copy and complete the table by drawing some polygons. I'm going to use this little tool over here, and I want you to do something as well. Oh, that's tiny. Can I make that bigger? Nope. Oh, that's an interesting thing to do on this website. I had not seen that before, that you can possibly make some congruent figures from the ones that you choose. Okay, so there's a triangle for you. For the hexagon, let's see if we can insert a line. Oh yeah. Might be too hard to make it equal. I might be better off just drawing this, but I'm excited to see this feature. So there's a hexagon for you. It should have 6 sides, and I'm going to do the rest just by drawing with my finger. It should look something like this. Oops. Let me draw it down here. 6 sides. Okay, quadrilateral should look something like this. Okay, any type of quadrilateral would do. A pentagon generally has the point at the top, or the vertex at the top, and then those 4 sides. Sorry, that one's crooked. And then finally an octagon. Think of a stop sign for that one. Okay, so it's something like that. Next, we are going to identify the angles and label the parts of the shapes. So for identifying the angles, each part on the inside where 2 line segments meet is an angle. So you should be able to go all the way around, and this octagon would have 8 angles. And then we will label the parts on the outside or exterior of the polygon. On the exterior of the polygon where 2 line segments meet, we call that a vertex. And then the line segment, we call that from the outside of a polygon, the side. Okay, so here's another side on this pentagon and one of the vertices on this pentagon. Okay, and then this pentagon also has as many angles as it does sides. So if there are 5 sides, it's got 5 angles and 5 vertices. Okay, let's name the quadrilaterals, excuse me. So this one right here we call a parallelogram. 2 sets of parallel sides, they don't have to be equal though. What do we call this? A square. Oops. So where? Now it's got 4 sides, 4 equal sides, 4 right angles, and 2 sets of parallel sides. Over here is a rhombus. Usually you will see it kind of on that vertex. And it looks kind of like a diamond. And now a rhombus has 2 sets of parallel sides. There doesn't need to be right angles, but the sides are all equal. Next, it's a trapezoid. Only 1 set of sides is parallel in a trapezoid. As soon if these lines here were parallel, it would end up becoming a parallelogram. And finally, rectangle. All right angles, but the sides are not necessarily equal. Okay, we're going to choose true or false for the following questions. Would you say an outline of an envelope is a quadrilateral? True. The outline of a star, is that a quadrilateral? False. And you can see here how many sides a star would have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So not a quadrilateral. It has 10 sides, which is a decagon. I don't know if any of you know that one. Probably some of you do. Next, a square is a special type of rectangle. Is that true or false? True. A rectangle just needs 4 right angles and 2 sets of parallel sides, and a square has that, but it also has those equal sides. Does a rhombus have 4 sides of equal length and 4 right angles? False, it doesn't have to have the right angles. Trapezoids, are they a pair of parallel lines and 4 angles? True. Only 1 pair of parallel lines, just like they said. And does a parallelogram have 2 pairs of parallel sides that are of equal length and 4 right angles? False. The reason that's false is because they don't have to be of equal length. Now we're going to check to see, are these shapes congruent? To be congruent, they need to be the same shape and the same size, even if they have gone through a flip, a turn, or a slide. Are these? Yes, they've just gone through a turn. What about these? No, they're a different shape. And these stars? No, because they're different sizes. Okay, now we're going to look for what has happened with these shapes. Have they gone through a slide, a flip, or a turn? With some of these, you could say multiple answers, but they're showing you with the line and the dot here to help you kind of see what is really happening. What about the letter A here? Slide, flip, or turn? A flip. It would look the same if it went through a slide. However, we're going to say flip for that because that line is helping you see. It's like a mirror image. Since it is a symmetric figure, though, a slide and a flip would look the same for it. Over here, this red dot helps you to see what's happening to this shape. The square that was on the top left-hand corner is now top right. It's a turn. And over here, the little stars, what's happened here? A slide. A slide can be diagonal. Okay, next, we're going to see, are these figures symmetrical? If they are symmetrical, then the 2 halves are congruent. Does the little girl have a line of symmetry? Yeah. If we draw it right here, there's going to be 1 pigtail on each side, 1 arm, 1 leg, 1 eye, and half a smile. So the 2 shapes are congruent. Oops, we got to switch. We're going to put yes. Does this have a line of symmetry that we could draw? Yeah.